Hi, everyone. Welcome to, I believe we're third class, right? Okay. And I'll just make sure I could set up the uh, speaker. So just in case somebody, same as system display. Dell, that's definitely not mine. Okay, audio driver, display audio. I don't know which one is Dell. Uh, Oh, it's the same thing. Okay. So I think if you say something, I should be able to hear you. If you're speaking from home, anybody want to say something so to see if it works?
No.
Um, Anybody? Let's see, the chat. Somebody say something. Uh, who can see your messages? Answer. Could you say something? Somebody try to say something. Just want to see if
Hello.
it works.
Hello, hello.
Uh, it doesn't look like it's working. Um, I don't hear anything, so sorry. Uh, I'll figure it out. I think video. I don't see it. Speaker is only. Oh, maybe I could test it. Hold on. Yes. Hello. Uh, Maybe it's this one. Hello.
Hello.
No, I'm sorry. That's a microphone. Uh, how do I do that again? I do audio. So I want to see if it works again. So I want to test speaker microphone. So, hello. It should be on.
Hello.
Video mute. Uh, what is hold on a second. Left turn gooseneck is off. Program file. No, it should be on. Maybe that's on. Just try this one. Okay. I can, somebody want to say something?
Hello, Professor.
Yeah, hi, I can hear you.
Amazing.
Okay, we have liftoff. Okay, great. Uh, so I just wanted to quickly take attendance for those who I missed so far. Uh, and then we'll start the presentations. We had figured out how to, oh, wrong password. Um, Too much technology, right? Okay, and just bring up the spreadsheet. Oh, people here could see the spreadsheet. Um, it's been so long since I've used a regular keyboard. Not used to it. Okay, so the people I'm missing, I have Ashley Cinderin.
I'm here, Professor.
Oh, you're here? Okay. And let's see who else I'm missing. Luis Rodriguez.
Hello, Professor. I'm also here.
Yeah, I thought I saw your name. And uh, and the last person that I don't have is Ahmad Zubar. Zubair. There's only one I don't have. Is attending. Oh wow, that's really cool. Okay, so just number one. Yeah.
I enrolled in class yesterday.
Okay. Just send me an email then, okay? Okay, I'll make sure. Yeah, but so far the only person not here is, he's what?
He dropped.
Oh, he dropped the class? Yay. I mean, not yay, but you know what I mean. Okay. Yeah, send me an email. Okay, so everybody's here then. That's great. Okay. I don't have to keep taking attendance. Okay, so now I'm going to turn over the lectern to our two presenters. I think, right? You're here? Anybody presenting today? You can't do it from home. You have to be here. See me to share my screen. So we have anybody presenting today or not? So we had, or maybe it's the fourth. What? I'm sorry? Oh, fourth is two people. Okay, thanks. Okay, that's fine, but I don't want to, yeah, I don't want to wait till the end of the, semester and all of a sudden 20 people want to give a presentation and and we don't learn anything. Yeah. There's like 35 students, two a day. Two twice right, two people, 5 minutes each right at the beginning.
Student, we will present once.
Yeah,
Okay.
and then there's a project also. Yeah, that's after the midterms. Okay. Okay. So fine. So let me just finish up what we were doing and then we'll move on. Okay, so I think I uploaded the latest over here. Let me just check. And because I had to, Google Docs is not as good as here we go. Here's our folder. And we left off over here. Okay. So so we went through coding. I'm pretty sure I uploaded. Though I can't maybe let's make sure I so many things. Let me just see. Oh, it was called class. This is what I was working on. So it's called class 2. Is that what this is called? Yeah. Okay. So it looks like I uploaded it. Okay. So I just wanted to finish off this document. So we spoke about just a brief review. So basically, we spoke about in general what is software engineering, and we said that software engineering is the development of a software project, and pretty much everything around it is part of considered to be software engineering. So from the time when you decide whether it's possible to do it to the time when you're already done with it and you're ready to do the next step. Those are all the steps that we went through. Then we said how technology has changed the process because of the rapid technology and the global competition for software. So that has changed. That basically everything has to come out quicker than it used to be, right? Oh, I see. I only put in. Oh, and then, okay. Then we spoke about, I think we left off over here, which were the buzzwords. So buzzwords are always good for job interviews. So, but you should just understand what the buzzwords mean, right? These are like common terms you'll hear. So performance, we said, is the ability for like, just I always think of a high performance car. That's how I remember what it means, right? It means that it's going to go fast usually, right? That's usability, we said basically is how quickly, in other words, basically nowadays most software is very usable, meaning that you don't need to read any documentation, how to use it. Yeah, and then reliability is sort of like, like basically it's another word for dependable, right? It won't crash too often. So like something like it's up 99.9% or something. Like you go to some websites and they promise a certain amount of reliability. Yes. Oh, I'm sorry. Sorry, I had the wrong thing clicked. Okay, sorry about that. Anyway, so far it's just reviewing. So then we're up to reliability. And then it's funny because the people at home saw more than we did. Sorry about that. Okay. And then we have functionality, which is that, okay, this is where we left off. So functionality is basically, there's two types of functionality. Functionality basically is what did the user ask for? Okay. So in other words, they'll ask, for example, we want software that will, store, let's say accounting software will store the chart of all the payments made and stuff like that, right? So that would be a functional requirement, right? You need to keep a general ledger, you need to keep track of all the transactions, blah, 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 right? So that would be very specific things that the customer would want. Non-functional would be things that are more like fuzzy, or actually it's not really fuzzy, it's more like general. So for example, my favorite example is like if you go for any website, you see that it's pretty hard to find a website that's not like you go to Google, for example, over here. This is how do you tell it's secure? How do you, there's a way of telling, right? Is this it? Oh, it says over here. It used to even, they even gave up on doing it, right? They used to put a lock on top to show you that it was secure, but now they don't even bother doing that. They just, um, I, I guess I don't know how they tell you, whatever. So they don't bother showing you a symbol of a lock because it's so common that it doesn't bother. So it doesn't even bother mentioning. But like if I would copy this this URL, right? Let's say I put into not here Notepad, and I have a new version of Notepad. It opens up. Um, Yeah, so if you go over here, you'll see the link actually, I'll try to make it bigger, is actually starts with HTTPS, which the S stands for secure, right? So basically the idea is that if someone wants a website from me, they probably want it to be secure. Why? Because that's the default nowadays. So a non-functional requirement would be something that's basic or very broad or implied. Right? So I think I gave another example, like if I ask, say, hey, could you get me a Coke from the kitchen? So I probably want the one in the fridge, not the Coke that's, in the storage drawer, right? Or the storage cabinet, right? I want something cold, right? If it, right, so that's sort of like an implied thing, or or non-functional could be also something that's broad that covers many different features. So like security is something that's broad and it's not specific to any one feature, right? And we're going to see later on that non-functional requirements are actually much more important than functional because they cover more. In other words, even though it might not even be specified by the user as a requirement, but since it's so broad, right, then if you don't do it, most of the time, the project will fail. Okay, right? Because imagine you can't sell the government. If they're buying a website, you can't give them a website that's not secure, right? It won't go anywhere. So you have to, in order to get, to even look at it, it has to be secure. So um, so that would be an example of a non-functional requirement. Okay. That's why I wrote over here, but we'll get into that later on. Okay. Um, and so non-functional is very important, even though it might not even be specified by the user. Okay. Maintainability means that it's easy to fix, which basically means that the code is clean, right? Maintainable code is means that the code is written in such a way that people could find it easy to to fix, meaning that, let's say somebody leaves the company and 2 years later, someone else is working on that code, that they'll be easily or pretty easy for them to fix the code. It won't be like I was just looking at someone's code at work and I think they wrote 150 lines of code. And I couldn't believe it because, I mean, because where I work, most of the new code is like very, like 1 or 2 lines. And this guy wrote 150 lines. You try fixing that. I could see the problem, but I had no idea. I didn't want to touch it, because it was too scary, because I wasn't sure exactly, I guess I could have if the person left the company, but instead of fixing it, I just, said you touch it. Yeah, you deal with it. Yeah, 150 lines is a lot of code, right? This time also like very concise code, meaning that each line does a lot. So, and it was no comments at all. Yeah, so took me a while to understand it, and once I understood it, I saw that it's not gonna be easy to fix it. So I just let him deal with it. Um, but that's not a good idea, right? That's not uh maintainable code because I didn't want to fix it, right? It's not easy to fix because if I would have had to change it, it would probably I would have broken it up first thing, right? From 150 lines to blocks of code or something, right? I wouldn't have done it. I wouldn't have kept what that person done. But once you change that, then you risk breaking the whole thing, right? So that's the problem with code is if it's not clean, then everything is too interconnected. And when you fix one thing, you break at something else. So, so when people are lazy, they just add like an if statement to existing code rather than actually make it clean. So clean code basically means code that's easy to understand and also easy to fix, right? So it's basically easy to understand. And usually it's also um, it's it's also small amount. In fact, I shouldn't say usually. It always is. It's that a code is made up of small parts. Okay, so a good like for example, a good code. I mean, it used to be that they would say that when I first started working, they would say like your code should be like every 5 lines of code you should put a comment. But now I would say it should be your method or functions should not be longer than 5 lines. If it's longer than 5 lines, then there's probably a good chance that it's too complicated, right? So, um, yeah, so I would, you shouldn't have like 100-line methods or functions that should be broken up. So it's easy to fix. And then comments, I was speaking about, I think before also, about documentation. So the same applies to comments where it's not good to have too many comments because if you write a whole, long explanation of what you're doing, then when the code changes, the comments are worthless. So you should basically, what I recommend or what we do where I work is we don't have too many comments. But we do comment where um, something unusual is being done, right? So normal basic code, let's say code that's going to get, the first 10 people in the class or something like that, or something that's going to update all the grades of people in the class. Something like that would be just, simple method. You don't really need a comment for that. But we're doing something weird. Let's say you're modding by 21, and why are you doing 21? Like, you have to explain a little bit what's going on, right? So comment where something unusual is happening. But that for sure you should do, right? Or were you doing some, a really large method, which you really should not be doing. Okay, things should be broken up. Okay, security. Um, okay, there's another thing. So the reason really I brought down security is to is not distinguish, to dis no, it is distinguish, is no, to show the distinction between what?
G.
Differentiate. Okay, that's a safer word. Uh, between security and safety. So safety means security means that um, that my data is protected, my program is protected, but safety actually means that no one gets harmed by it, right? So it's totally different ideas, right? Safety is like if you write software, let's say that flying is a drone that won't go crashing into people on the ground by accident, right? And security is basically what we know is security is basically that only me and let's say Amazon know what I'm ordering, right? Everybody else doesn't know my credit card number and all that stuff, right? So that would be security. So safety is a little bit different, right? Um, okay. Um, yeah, I don't know how people like write, safety type of software, like how they go to sleep at night. I don't know. Like if you imagine those people write the code for like a heart thing, a heart, what's it called? A pacemaker. Like I don't know those people. It's scary, right? Or or stuff that flies in the airplane by itself, or it's scary stuff. Um, to me, it is. I don't know. Maybe some people feel really confident in their code, um, or maybe they just test it to death. I don't know. I think there's one play I read somewhere where an Airbus, when they write software for an airplane, what they do is they write a software box around it. So even if the software makes a mistake, they don't allow like certain things. Like you can never, let's say, put the plane at a 45-degree angle. Like there's certain boxes, combinations that they'll never allow. So then they could go to sleep at night because they know they want nothing crazy is going to happen. Like maybe the plane might might be some software errors, but nothing crazy, so it's a little bit safer. Like they put a box around it that like protects from doing crazy things. Like if you know that you never want your airplane to go, certain miles per hour or at a certain angle or whatever. So that then you could do that. Um, Okay, so then the last part, this is from the book, um, but I thought I'd just go through it quickly, is what are the different types of software that could be written? So, of course, you could have different ways of categorizing software, but this is basic. I think this is the book does it. Yeah, I think the book did it. That does this. So basically, they give, I think, even more, but I think these are more distinct types of things. So one type is standalone. Basically means basically software you could play you could use um, like without any network, right? Something you could play in the subway, in the submarine, wherever this, you still could use it. Like Microsoft Word, right? That would be standalone software. Transaction-based software, though it's getting less and less the amount of standalone software, right? Pretty much everything is web-based, right? Um, but there's still some programs that are standalone. Um, transact like calculator, yeah. Try to think of what else could be standalone. There aren't too many. Then there's transaction-based software. Now, does anybody here take databases? Okay, what's a transaction? A database transaction?
Take it,
What?
insert something inside of
What?
insert data inside of a database, take it, like information of data.
Right, but why is it called a transaction? right? Yeah, yeah,
Single unit. Treated as a single unit.
say again?
The operation was treated as a single one, not as a freedom.
The operation was,
The like only one. That's the condition that manipulating the database against the database.
okay. I think what you're saying is that, no, it's even though you might be, let's say, reading and writing, right? But it's all done together, right? So, or if you're doing many things, like either they all succeed or they all fail. So transaction means that basically it's sort of like we're like account anything that has to do with like basically anything that stores data, you don't want to save half the data, right? Let's say you're writing to three tables, you don't want to save and let's say crashes, someone pulls the cord while it's writing to the tables. So we already wrote to two tables and the third one it never wrote to. So you don't want that to happen, right? You want either all the data or none of the data, right? That's a transaction. Okay. So data is important. So those are transaction-based software. Okay, so that's another type of software. Now we get to this embedded software, which I don't know a lot about, but I do know uh, um, I know its properties. So embedded software is like software that runs inside a chip. You correct me if I'm wrong, okay? So the way I understand it, it's software that's tightly connected to something like some computer chip. Like, for example, when you open the door of a refrigerator, the light goes on, right? So there's something, it's usually a computer chip that gets activated when you open the door, and maybe it also does other things besides turning on the light. Maybe it lowers the fan, right? Or something like that. Stuff like that. So basically, it's software that's controlling either it's written on the chip. See, I'm not 100% sure exactly how it works. Does anybody know how it works exactly? Like either it's written into the chip or it controls the chip, whatever. But the point is that it's very tightly it can I think it's like yeah, like when you buy a refrigerator, the software is there, right? It's not like you have to download stuff to run your refrigerator. Um, though maybe Tesla's different. Yeah, yeah, but basically when you get a microwave refrigerator, it works the way it works, never changes, right? So the software that controls it is part of the hardware. So that's what embedded software be. So it's basic, okay, so it's really it's very tightly coupled with the hardware. And the reason why it's so different in this book, they like using this as an example because because it's so tightly coupled to hardware. So then when you change the hardware, you have to change the software. And the other way around. And when you change the software, you might have to change the hardware, right? Um, so that's what makes it unique. So again, standalone is unique in the fact it doesn't need a network. Transaction-based is that it's software that's written to save data correctly. It needs to save data correctly. Embedded software is different in the fact that it's tightly coupled to hardware, making it very expensive or making it, it's making that you can't just change the software without thinking about the hardware aspect of it. Um, and then there might be more to it than that. I really don't know exactly how it works. I used to have some in my class who actually worked on embedded software. He did it for a company, I think they used to track trucks or something like that, send out GPS signals. Not sure exactly. I think whatever, but yeah, he understood how this works. But anyhow, so that's basically the software. And then there's web software, which is we said was different because it's always client server. That's what makes it different. Meaning that there's always anything that works with something on the web, right? You're going to have the web which does the processing or some type of processing. And then you have the client, which is not on the web, right? So you would have a browser, I don't know, like something like, I forgot, what does Amazon have? The little devices that listen to you? Or like, what's it called? Alexa. Yeah, Alexa. They have they have a couple, right? There's Alexa, there's a small, I don't know what they got. They have a couple things. Yeah, I would not recommend having them listen to you. Yeah, I was once talking to my wife in the car and I said something and I said, oh yeah, yeah. I said you could Google it. And then all of a sudden Google started recording what I was saying because I said, yeah, why don't you Google? All of a sudden, like I saw in the car, it started, everything I said after that was being recorded. Yeah, so, yeah, that'd be scary with Amazon. Yeah. With Alexa, let's say you have a relative named Alexa come by, you say, hey, Alexa, and all of a sudden everything you say is being sent to Amazon. So kind of scary. Um, Okay, so then we have game software, and again, these are all arbitrary categories. Like whenever they say, 10 things you shouldn't do in an interview, it could really be 15, 20, or 5, right? It's just like people always like making, categories, or there's 5 types of people, or sometimes you read a book about there's, different types of people. Some people are this type A, B, but it's just all arbitrary. So, game software is different in the fact that it has to be fast, right? And have good graphics, right? So I wrote graphics and also speed, right? So speed and graphics are critical, right? You don't care about accuracy with games, right? Or for crashes, right? Because, and you don't care about saving data that much, I don't think. So the main thing is it has to be cool, right? It has to be interesting. Um, and you don't care about if it crashes once in a while. No one's gonna die, you know. You just start the game up again or something, right? Um, and then I've heard though that they have like people who have they have AI playing games for them. I don't know. Or it's like they try to have, I don't know, they like have the game, I don't know exactly understand what the fun would be, but they try to have like AI play games to get like higher points or something. I don't get it. Uh, anyhow, so, um, or maybe they write macros that do this. I don't know. So anyhow, but I don't like game software personally. I just like writing software. I don't like playing it. I don't like using software. I like writing software. That's fun. So anyhow, financial software, you care about obviously accuracy, right? And sometimes speed. So basically, you always got to worry about accuracy when you're dealing with money because, like think about it. Let's say you're dividing a dollar 3 different ways, right? What happens to that penny in the middle, right? You have $1, right? So what happens to what do you do with a penny? So there's actually a certain way of doing it that, where you don't lose that penny, where somebody's going to get that extra penny but you don't want to lose it because then things don't add up anymore, right? So you need that accuracy and also like if with computers, especially with doubles, if you use doubles, you're going to lose. It'll be like if you do, let's say, 6 divided by 3, let's say, you might end up with 2.0001. Like the very end, there might be some thing hanging out, or you might get 1.99999. So you got to be very careful that might be okay for regular things, but when we're dealing with money, then you have to be very accurate. So I've seen like a lot of software, not a lot of, I've seen like some software, what they do is they store things as pennies. So they don't have to worry about like how do you store a dollar instead of storing $1 as 1.00, they'll store it as 100, right? They just store everything as pennies so they don't lose any information, right? So, there's no quarter, they don't have to worry about storing a quarter of a penny or whatever. And then speed would be important. Let's say that you live in New York, we live in New York, and there's Wall Street, and Wall Street is all about speed, right? It's all about quick trading, right? If you ever work for a Wall Street firm, that's what they want. They want execution, speed. They want to be able to do things as fast as possible, right? That's why I think like you'll see that these trading companies, their software actually uses C++, which is like an old, or C, which is very old languages, but because it's fast, they don't care about how cool it is or how easy it is to program. They're worried about speed, right? That's what that's what's important to their business, is that extra second a trade takes that could mean a lot of money for them. Right. So in fact, I was speaking to somebody from Bloomberg, and he told me that every morning they check their software to see how fast it is. I think they might time it with other people's software. I'm not sure exactly how they do it, but they want to know, like, how is their software, at least, whatever, I don't know. But they're always worried about speed, right? I even heard that some companies are actually located where the internet comes out, so they get things a little bit faster. So the electrons have less distance to move. It's crazy, huh? Any edge you could get, right? So, okay. So, we're done with chapter 1. Okay. So that was chapter 1. And, okay. So we're good. So now I'm going to switch a little bit, and I wanted to discuss object-oriented. So I have, let's see, where did I put it? Here we have, over here. And where is it? Let's see, where did I put it? Well, I'm not sure where I put it. I'll just start a new document. Okay, so. Okay, so. Okay, I don't know. That's weird. Okay, so, so now I want to speak about is object-oriented programming, and OOPS stands for, right, object-oriented programming. Okay, so if you took C++ or Java, right, or both, do you remember what is the idea behind object-oriented programming? Well, first of all, I guess the first question is, what is an object? Let's say in C++ or Java, what is an object? How would you define an object? Right? Right. So anybody have any ideas? Yeah.
Instance of class.
Right. But what is a class? Okay. The answer is a class, right? The answer is, right. So the question is, what is an object? And the answer would be a class, right? I'm sorry, a class, right? Or a class would be a type of, right? Class is a type of object, and you're correct. An actual object is an instance of an object. I'm sorry, instance of a class is a object, right? Right. So for example, like humans refers to a general, person or human, but Fred or me, R.G. Greenberg, I'm an instance of a human, right? Right, so all of us here are all instances of a human being, right? So, but the type we all are, right, is humans, right? Um, so object-oriented programming, so what is an object exactly? So we explained that a class is a type of object, but basically there is a basic, um, there's something else, it's what does an object contain? So, okay, so the question would be, what does an object contain? So the answer for that would be it contains methods and data, right? Those are the two basic, it's really not that complicated, right? Methods and data, which means basically it has certain data and methods that that work that it usually, they work together. Okay? So these are the things that are a class, what does an object or a class contain? So methods and data. Okay, so basically when C++ or Java, or actually C++, that came before Java, I think. So when C++ was created, there were four object-oriented principles that were supposed to, I'm sorry, that actually came with the language, okay? So does anybody know what the four basic principles? These are like the four, the original four ideas, and then in this course we're going to cover a couple more. Okay, so the original four are what? I'll give you a hint. The first one is, let's say, inheritance. Uh, what? Actually, I should do one. I'm sorry, what? Yeah. Somebody said polymorphism. What? Yeah. So one is going to be inheritance. Okay. Second one's going to be polymorphism. Anybody else? Yes. Good. Good. Polymorphism. And then abstraction. And what's the fourth one? I forgot myself. The fourth one is, don't Google it. Is encapsulation. Okay. So what is the idea behind what is the idea behind these four things? Okay, that's what I wanted to cover today. So, so the idea behind inheritance is what? What's the no? Why is it? When C++ came out, people thought it's going to change, revolutionize the world, right? Because of inheritance. That was like the one thing. I don't really remember the other ideas so much, but inheritance was a really big idea, right? What was the idea? It was like the holy grail of programming when C++ came out, because it was like the ultimate great idea. Okay, does anybody what's the idea of inheritance? Inheritance allows you to what? To reuse code, right? Allows code reusability, right? Because all you have to do is inherit from that parent, and then you get, wow, you get everything the parent object does, right? So allows code to easily be reused. Okay, so people at the time thought that inheritance is good. It was a great idea. Now, it's actually not such a good idea. Could anybody guess why inheritance is not a good idea? Might not be such a good idea. Well, if you imagine you have one parent class and you have five children classes, what happens when you change the parent? Then you're going to you affect all the children. And what happens if you have grandchildren and you change the grandparent? Then all of a sudden you just, you unwittingly might have messed up, dozens of objects without even realizing what you did, right? Because you might try to fix one thing, right? So inheritance allows it to be reused, but we're going to see it's actually a little bit dangerous, right? In fact, most people where I work, when they do inheritance, I get really scared because it's really scary to change a parent class because you don't know, it's hard to understand, after a while, after years and years of being, used, is to know what's going to be affected when you change a parent. So most people, I personally never change. I usually don't because unless it's really obvious, because it's so easy to mess something up without realizing it. But anyhow, but the point is that when C++ came out, though, inheritance was the best idea because we're gonna save so much time writing code. We're just gonna inherit from a parent. You reuse all that code. Everything's gonna be terrific. Okay, so that was the idea. Polymorphism was another idea that came with C++, because I don't know if you ever took C, I don't know if you ever took C, right? Because they always taught C++, but C alone, did not allow to use the same method. So for example, in C, this is an example of polymorphism. Okay, so from C, for example, you would have, let's say, a method called print, and it would be print string, and then you would have another one called print number, and then you would have another one called, print date. So every time you couldn't reuse um, the same name twice, right? Right. So for example, if let's look at, I'm going to do a little Java program, just really simple. Again, remember I told you to download IntelliJ or whatever else you like for Java. I really like Java. Uh, it has a couple, I mean, it's good definitely for teaching. Um, let's cancel that guy. Um, but you can't be free, right? So, um, okay, new project. Okay, um, we'll call this, oops, principles. Principles for, okay. You could watch how I do it, but you should try to do this yourself. Okay. So basically, let's say we have over here, we have this main method, and I don't know why it does this. Okay. So over here, let's say, for example, okay, so what does this do? If we run this, it's the famous hello world, right? So basically, it's typically the first thing when you're learning a new language, that's usually the first program you write is hello world, just to show that you could do some output, right? So if we run this, it says hello world. You see that at the bottom, right? Can everybody see that? If you want, I could turn off the light, um, or make it. No, I can't make it big. It's hard to make it bigger. Now let's say I want to print out. Now it's really cool about Java is I could print out let's say 1, 2, 3, or I could print out, let's say a date. actually I could print out 1, 2, 3, 4, 5. And then I could also print out, let's see, a date. I'm not good at this. I think it's called, I forgot it. In Java, how do you say a date? It's system date or uh, it's one thing that it's very confusing. Date that if I did this, I did date that t equals to new date. Will that work? Okay, I'm more familiar with Java. I mean with okay, so I don't know what that's gonna print. But like so let's say we run this again, right? It's gonna correctly print out everything, right? So print 1, 2, 3, 1, 2, 3, 4, 5, and I'll do the date. I think it'll be today's date. Right. So it did so printed everything worked, right? It printed out this as and printed this as a decimal, this as an integer, this as a date, and then this as a string, right? So these are really four different data types, right? There's an integer, double, date, and a string. Yet we had the same method, or did we? Right? Right? Did we use it? No, it's how could we? That was magic. We used the same method for four different parameter types. How do we do that? Well, if we double click on this, we can actually see the library, and we see that there's actually a bunch of print lines here, and each one has the same name, but they're differentiated by their parameters. So there's a print line for a float, a print line for a double, a print line for a, this looks like an array, or oh, actually an array of characters. This is a print line for a string object. Oh boy, there's a lot of comments there. Someone wrote there. So actually, there's like a lot of different print lines there. Okay, so what it looked like one method called printline is actually a bunch of methods, right? And what differentiates them is their parameters, right? So when I use 1, 2, 3, the compiler knows which print line to use. It uses, so Caesar 1, 2, 3 says, well, I'll pick the print line that matches an integer. When I'm using a double or a float, I don't know which one. Actually, you can see which one it used over here. It used a double, right? It decided to do that one. And then when I did a date, it used this one, right? Prints an object. Oh, that's cool. And then this one, it did a string, right? So basically, the compiler decides when you build a program which one is going to be used. But from the programmer's viewpoint, right, they're all the same. You don't care, right? So so this is an example of polymorphism, right? Because we have the same name, but we could do what's called parameter overloading, right? Right? For example, in C, for example, we have all these, right? In C++, though, you could have you could have the same name over, makes it a lot easier, right? Print with different parameters. Okay, so now you always hear this polymorphism. Now maybe you understand. I mean, it actually took me a while to understand. So you get go for a job interview and they say, "Give me example polymorphism." Now you got it. Okay. By the way, I was asked this question in one job interview. They asked me, the four basic principles. I don't think I don't know how well I remembered them, but you're getting it straight. So you're going to do well. Okay, so we have print with 4 different parameters. Okay, so no need. I remember the old days. You had to keep on when I was programming in C. We had to keep on like you would have like like names like this: print string, print number, print date, and then you would have sometimes you would have to have you put like print string 1, print string 2. You know, if you had different numbers, different types of parameters, stuff like that. So we can print with different parameters. No need to repeat no need to create different names. Right. Also, another example of polymorphism would be, let's say we have a class called um, math, and then I love this. I mean, before AI, this is amazing because it like does all the work for you, like so it like sort of it's pretty smart. Um, so let's say, for example, I have a method called add. Let's say public. Does everybody know what public means? What does that mean? Public. It means that what does it mean public and private? What?
It's accessible by other less outside of.
Right. In other words, it's visible outside the class. Right. Very good. Right. So over here, for example, we have I1, and then we have int I2. So then we could just like return, let's say, is obviously a little bit simplified, but you get the idea. And then I could do the same add with 3 parameters, right? So I can't do 2 exactly the same because then it'll give me an error. So I could do something like this, and I could do like that. Okay? So then over here, main, I could do I could create, right, like you said, I could do math m equals to new math, and then I could do I could do, let's say, print, I forgot how I do it. I do, no, I type, oh, I'm beginning to forget it. Print line, there's a shortcut. I forgot what it is. Anyhow, so I could do, oh, I think isn't C out? C, no? There's a shortcut in IntelliJ for getting the print line method. So print, let me just copy over here. So I could, for example, I could print and then I could do add, I could do 1, 2, or I could also do 1, 2, 3, right? So again, I'm reusing the add method, but with different parameters, right? I could do this also, right? Right, so like both of these will work even though they have the same name. So again, I'm doing polymorphism, right? So one case I'm doing it with the type of the parameter, one with the amount of the parameters, right? I could do it either way, right? I could reuse the same name twice over here, right? Or over here, right? And in both cases, it's just they're really different methods, but polymorphism allows me to not have to create different names for it. Okay? Okay, there's other ways of polymorphism, but these are the most basic. Okay. Um, okay. We can have different we can print with different parameters, create different names. Okay. Parameter types. or number parameter. Okay, right, we saw you could do either, we saw you could do either of those. Okay, okay, so then finally we get, I'm gonna skip to 4 first, okay? Encapsulation, what is encapsulation? So encapsulation means to hide my data, okay? So basically, when I encapsulate, remember we said that a method could have two things. I mean, a class could have two things, right? Either a method or data. So encapsulation refers to, I guess, both of them, right? But more for the data, right? So basically, I want to protect my data. Sounds like a game, like I have to protect. Yeah. So encapsulation's idea is that by being in part of me, it's protected and my data cannot be messed up by another, let's say, a method. So for example, let's say, let's go back to this example over here. Let's say, for example, in math, we have um, let me think, what would be another object? Let's do something else. Let's do a person, okay? So in a person, you might have um, like an age, and then, let's say we have a, um, ID, right? Assigned ID. I should say not a signed ID. I would say a internal ID, right? So this is something that's not meant for anybody else, right? So this might be public, right? Meaning that other objects could change it, but this is a good chance I want to make this private. So when the person gets created, for example, I would, in the constructor for this object, I would maybe assign the internal ID equals to, I don't know, random. Does anybody know the random stuff and random? I forgot, equals to, uh, let's see, what's Java. By the way, I don't use ChatGPT because I don't want to forget how to program. So I try to do the most amount of work, least amount. So Java random number, random integer, uh, uh, is Java, it probably is math.random. Okay, so math.random. It's probably confused because um, I have my own, it probably doesn't know which math I'm referring to. Did not resolve. Um, let me see that again. Oh, Java util random. Let's use this one. It's probably more, um, it just because it doesn't conflict with because it's a little confused probably because I created okay. Now this will know what this is, and then it's going to add it. Should add it automatically. Come on. Maybe this will work. Import. I don't know what just happened. Ports.
You have to import Java util.
Yeah, but why doesn't it do that? Yeah, I thought it would do it for me. Usually they ask, was it import java.util? Util? That, oh, there you go. Yeah, very good. Thank you. Okay. Uh, maybe not. Just this, maybe. No? Import or is it imports? What?
I think when,
No, usually, yeah. Oh, you're right. Okay, good. Okay, so then this should be lowercase. Uh, I'm not sure why it's not working. Anyhow, but the point is, let's just do it I'll just make it equal to -1 right now, okay? The point is that we have encapsulation says that no, let's say we create a person over here in main. Let's say we say person P equals to new person. So over here, we could set the age equals to whatever we want it to be, 23. Uh, but we can't set or we shouldn't be able to set the private stuff, right? The internal unique ID, right? Over here, right? We can't set this. We don't have access to it. Only the object itself is able to modify it, like, for example, in the constructor or somewhere else, right? But no one else could mess it up, right? So that protects my data. So that would be an example of encapsulation, okay? So that would be, because does that make sense? So basically, by hiding it, it gives it, so then if something goes wrong, right, I don't have to look at, well, if the age is wrong, then I might have to look everywhere for that, right? But the truth is, there's something else in Java. I'm sorry, there's another idea called of encapsulation, which is even something like this, which could be changed, right? Is there's another idea of using a getter and setter. So the idea is even if I want this to be able to be changed, right? There's actually, I could do something else here. It'll let me to generate a, a getter and setter. So what these are going to do is they're going to so even though the age is private, I made it private, but I made public these two methods which could change it. So for example, over here, I can't do age anymore. I could do set age. It's a little bit of a pain. In other languages, like in C sharp, it's actually you don't have to you could just use a different word and it like under the hood creates it for you. I think C++ also does that. It's called I think a property in C++. So basically instead of doing getter and setter, right, you do whatever. But the point is that I have a way of, even in this case where it's public, I have a way, for example, um, of controlling that the age can't be a crazy value. For example, I say if age is less than 0 or less than 1, it can't be less than 1, then I'm going to return, oh, you could be 0. Oh, yeah, you could, let's say 0, right? Then return. So for here, I won't allow garbage values. I could control, I could still protect my age by making it private. And the only way it could be returned, only in that controller example, and let's say it can't be set to a crazy high value. So let's say I want to make maximum age. I don't know. What would the max be? Let's say 100. let's say I don't want any ages that are greater than, let's say, 150. Okay, so again, I'm protecting my age variable that it won't get modified to crazy values, right? So that over here, this part isn't really so useful. But again, like for example, I let's say, uh, yeah, in this case, there's really no reason for the getter doesn't really have any logic in it, but we just have logic over here to protect the setting of the value. Okay? But we also control, if we want, how the age is viewed outside, right? So for example, we could always set it to 0 so people don't know your age. I don't know. It doesn't make sense. But sometimes it does make sense. We want to control how this data is viewed by outside the class. Okay? So and then over here in main, it could be used as say oh, it's S out, that's what it is. S out is the shortcut for print line. And I could do, for example, I could do P dot get age, right? So, and here we'll print out 23. Okay. Right. But if I set it to, yeah, but if I set it to 150 or let's say 151, it's not going to work, right? So then the age will just be 0, right? Stay at the value, right? It won't let me, right? So now it won't let me set the age to a crazy value, right? So it was just by default, all variables are set to 0 in Java. So what else do we leave out? Oh, abstraction. Abstraction is really, if you look it up, I'm telling you, I was like, scratching my head a lot about this one because it seems like very complicated. Then I realized the abstraction is really the simplest idea. Basically, the abstraction idea is that when an object does something or anything, so anytime an object has a method, right, then then I don't have to know anymore how to do that thing, right? So for example, I don't have to know how to spell anymore because I use Microsoft Word and it corrects my spelling. So, and I don't have to remember phone numbers anymore because my cell phone keeps track of my phone numbers, right? So when an object does something, I don't need to, I don't, I don't need, I don't need to know how that how to do that thing, right? So basically, any method in a object is a abstraction, right? So for example, over here, we have math. It's doing the adding for me, so I don't have to remember how to add, right? Once I have this method, add, I don't have to remember how to add 2 numbers or 3 numbers because it's taking care of all the work for me, right? And so that's any object with anytime you have a method, then it's basically doing something so I don't have to know how to do it, right? So that's called abstraction. The reason that's called abstract is because to me, it's a concept that someone else is going to take care of, right? That's why it's called abstraction. Because, right, so from my viewpoint, I don't, I know all I know is I have a method that's going to add 2 numbers or 3 numbers, but I don't have to know how it does it. Okay, so that means it makes it abstract to me. Okay, so basically any method is a abstraction. Okay, do that thing anymore. So it's abstract. Okay, again, it gets very confusing if you Google it. You'll find different definitions, but I think this is the basic idea. It becomes that, so it's like an abstract idea. Okay? So we did the big four. Okay? And we're gonna have more principles as we go, but these are like the big ones. These are like the job interview ones. They're the ones everybody knows about, right? We'll do a couple more that have been added on since then. Okay? So see you. Sorry for keeping you a little bit late. Okay. So see you on Thursday. Yeah, thank you. All this will be uploaded. Everybody's here, I think. I only took it one time. What? But I took the times before, right? Yeah, everybody's here. Yeah. I only do it once a semester. Oh, should stop recording. Okay, everyone, good night.